So we have one more example that just goes and talks about how we find the probabilities and our x values for our normal distribution. So example 10 says IQ is normally distributed with a mean of 100 and a standard deviation of 15. Suppose one individual is randomly chosen. Let x equal the IQ of an individual. So it says, how is x distributed? So they say, right, that x is normally distributed. So x is normally distributed with a mean of 100 and a standard deviation of 15, right? So there's my mean, standard deviation. So B says, find the probability that the person has an IQ greater than 120. So probability that x is greater than 120. Sketch the graph, shade the corresponding region, and find the probability. Okay, well, so if I shade my curve, right, here's my curve. I have 100 is right in the middle, and then I have, right, so 115, 130, 145. And then if I go the other way, I have, right, 85. I have 70, and then I have 55, right? So it wants greater than 120. So 120 is, somewhere over here, and I'm shading this way. So since we want to find the probability, we're going to use our normal CDF function. So my lower limit is going to be 120 in this case, right? That's the lowest value. My highest is going to be that 99,999, right? Because we're just sort of going to positive infinity, but we can't really say positive infinity in the calculator. So we just choose a large value. My mean is 100 and my standard deviation is 15. So if I hit second, vars, we want our normal CDF. We want 120 for the lower limit. The upper limit is 99,999. And then I have 100 for the mean, and standard deviation is 15. I'll go ahead and paste that. And so I find, right, the probability is roughly 0.0912. Now, if it wants it as a percentage, you then, of course, can multiply by 100 to find that is roughly 9.12%. So that would be the probability that the person has an IQ greater than 120. All right, so let's take a look at C. C says, Mensa is an organization whose members have the top 2% of all IQs. Find the minimum IQ needed to qualify for Mensa. Sketch the graph. Okay. So it's the top 2%. So we want to find the minimum IQ needed. So if I graph this here, all right, so if I'm thinking the top 2%, right, that's this little piece here, 0.02. So we're going to need to use our inverse norm for this one. So if you have the newer version, right, inverse norm, you would put 0.02. You'd put the mean, because we want the actual x value, right? We want to know the IQ of the individual. So the mean would be 100. The standard deviation would be 15. And we would say this is to the right. Okay? So if you have the newer one, it's actually a little bit easier. If you have the older version, we need to get the area in terms of the area to the left. So what we would do is we would take 1 minus 0.02, which would be 0.98. So 0.98 is the area to the left, right? That would represent this x value. So if you have the older version, remember, you would then type in 0.98, 115, right? You don't have that option of what the tail is. So you would hit second and vars. You'd go down to inverse norm. And based on the model that you have, right, this format would look a little bit different. So since I have the newer one, I'm going to type in 0.02. I'm going to type in 100, and I'm going to type in 15, and I'm going to the right. Okay, so paste that. And whether you have the older version and just did that, what I have in the second line, you should get that x is roughly, so 130.81. So if you were going to qualify for Mensa, you would need an IQ score of at least 130.81 in order to qualify. All right, so our last one, it says the middle 50% of all, let me just add a page really quick so I can scroll up just a little bit more. There we go. So it says the middle 50% of all IQs fall between what two values? Sketch the graph and shade the corresponding region. Okay, so if I shade my region, so we want the middle, right? The middle 50%, right? So this is what we're going for. So we have x1, what is that? And x2, right? What is that? So this is 50%. So I know, right, I have a total of 50%. If I divide, right, left of my 100, divide that by 2. So each of the tails, right, are 25%. So 25% here, 25% here, or, right, 0.25. Okay, so with this one, I'll do what we would do if you have the newer version. So the newer version, inverse norm, you would do, right, 0.5. You do the mean of 100, you do the standard deviation of 15, and you would say center, right? And you should be good. It should give you the two values. Now, if you have the older model, you're going to have to use inverse norm twice because we have the two x values. So the one below, right, would be, so let me do it a different color so you can sort of keep up. So inverse norm, you would do 0.25, 100, and 15, right? And that would give you, this is going to be what x1 is. Now x2, inverse norm, you need, right, so if it's 0.25, this little piece here is 0.25. Then from here all the way to here represents, right, 0.75. So 0.75, 115 will give you your other x value. So again, if you have the older model, you're going to have to enter this twice. If you have the newer model, like I have on my emulator, it's just the one time. So second, vars, we'll do inverse norm. Area is, for me, is 0.5. Mean of 100, standard deviation, we're going to the center in this case. We're going to paste that. So I get the two values, right? So x1 is 89.88 and x2 is 110.12. Okay, so these would be the two values that represent, right, the middle 50% of our IQ scores.